So we're going to review for the Chapter 5 test, which is tomorrow. And I thought a good place to start that would be the review problems from the chapter, the exercise at the end. Yeah. Okay. So this is a good problem to start out with, right? So so there are all kinds of Pythagorean triples, right? But this is sort of tested. Well, let's do this quickly. Just recap what we did yesterday, right? Which is here. And so we said, look, here are the concepts in Chapter 5, of which there are many. Unit circle equation, which basically says the distance from xy to the origin is 1, right? And so you have a little right, sort of want to imagine the unit circle with a point xy on the unit circle. And you can imagine a right triangle whose hypotenuse is 1 and whose legs are x and y, right? And by Pythagoras' theorem, the sum of the squares of the legs of a triangle, right triangle, is equal to the square on the can't even say it, hypotenuse. I want to say hippopotamus, but yeah, that would be wrong. And so the terminal point is determined by traveling distance t counterclockwise around the circle and arriving at a point where x is defined to be the cosine function, right, is the distance t you travel determines both an x and a y. And so those are functions of t, and we give them names, right? So the x coordinate is defined to be the cosine of t, and the y, the sine of t. And we have some special terminal points, which are, at these, they're all multiples of pi over 12, and sort of conspicuously absent from this list is 1 pi over 12 and 5 pi over 12, which we don't know how to find those exactly. Later on, you will learn how to find those exactly in terms of radicals, right? And so then we have these, the 6 trig functions, the 3 sort of original trig functions, and then the 3 reciprocal trig functions, right? And giving you essentially, there are 3 sides of the triangle, which means there are 6 ways to form a ratio of those 3 sides, right? You've got x over 1, y over 1, y over x, and then all the reciprocals of those, right? And those are cosine, sine, and tangent, and their reciprocals. All right, so the Pythagorean identities, we know x squared plus y squared equals 1 is the equation of the circle. All right, so that means then we can divide through by either cosine squared or sine squared and get these other versions of that same identity. Cosine is even, sine and tangent are odd. There's the periodicity, which sine repeats every 2 pi, cosine repeats every 2 pi, and tangent repeats every pi. Any multiple of pi will take you to a point where the tangent is the same. And then we have the graphs of these things, sine and cosine. I think we graphed a tangent here somewhere. Okay. Somewhere. And then we talked about, if you're here at xy, right? So cosine is x and sine is y, right? Then the opposite side of the circle is negative x, negative y, which we can think of in 2 ways. These are the negation of these xy's up here, or as going another pi units around the circumference, right? So t plus pi takes you to the opposite side of the world. The antipode. Did we ever talk about the antipode? I'm tempted to take a little tangent to the antipode. Antipode. I think they should be like, yeah, so it's the opposite side of the earth, right? Is there a little antipode online app? Yeah, oh, Oh gosh, this is like a political thing. Sorry. Goodbye, political thing. Antipode app um, and longitude and latitude. I'm wondering, what is our antipode? Um, Tunnel to the other side of the Earth. Okay, so we are over here. Uh, what's our latitude, longitude there? Are we getting different? Oh, well, that's New York, right? Um, so is this the antipode for where we are? No, this is, okay, so enter, okay, how about Palm Desert, California? Okay, so we're over here, we're tunneling to the other side of the Earth, and we end up where? Oh, um, just off the Madagascar, is that over there? Yeah, Madagascar. Okay, great. All right, let's get back to serious business. Um, so yeah, so to tunnel to the other side of our unit circle, we simply add pi to our current uh, distance from 1, 0, right? And or if you add pi over 2, then you essentially perpendicular, like, so a perpendicular slope is a negative reciprocal. So the slope of this line is y over x, right? It goes through the origin. So the slope of this line um, is the perpendicular slope, which is negative x over y. So you reverse the x and y coordinates and negate one of them. Which one? Well, if you're over here, then the x coordinate is negative, and so you negate that one. If you're over here, then the y coordinate is negative, and you negate the y coordinate instead, right? Okay. So transformations. So you have the generalized transformed sinusoid function, which is what? You've got horizontal stretch or shrink by a factor of a, and a horizontal or vertical, sorry, stretch or shrink by a factor of a, and a vertical shift by d, right? And then we've got what, omega t plus phi, which you can think of as omega times t plus phi over omega, right? And so the shift is phi over omega to the left, right? Unless that's negative, in which case it's to the right. Okay, so, and here's your generalized curve, right? Where you've got your phase shift, negative phi over omega, one wavelength down the road, and the wavelength is 2 pi over omega. So we add that to our starting position and get the position after one oscillation, right? And then at the halfway point and the quarter stops, which you can figure by, figure out what a quarter wavelength is and just add it repeatedly to your starting value, and you get those 5 points. Inverse trig. So for sine, we limit the domain so that it satisfies the horizontal line test. Do the same thing for cosine, but it's a different interval, right? It's shifted by pi over 2. So for tangent, we restrict the domain to negative pi over 2 to pi over 2. And should we take a look at so here's the tangent function, right? What does the inverse tangent look like? We could do a quick rendition of that, right? So let's put over here x and inverse tan of x, and you just reverse input and output, right? So if I guess we could say if we're at infinity, then the arc, the angle the arc whose tangent is infinity is negative pi over, or positive pi over 2. Yeah, that's kind of gimpy, huh? But we can say, yeah, if the arc whose tangent is -1 is pi over, oh, sorry, negative pi over 4, right? The arc whose tangent is 0 is 0, and the arc whose tangent is 1 is pi over 4. Right, so I'm just taking these input outputs and reversing them, right? And then, what about pi over 3? What arc will give us a tangent of, the tangent of pi over 3 is square root of 3. Why is that? Well, you can think of square root of 3 over 1 as square root of 3 over 2 divided by, 1/2, right? And so that's sine of pi over 3 divided by cosine of pi over 3. Are we recording this? Yes, we are. It's probably a mistake. Okay, so yeah. Okay. Does that make sense? So the tangent of pi over 3 is square root of 3, right? If you take the tangent of pi over 3, that's sine over cosine. The sine of pi over 3 is root 3 over 2. The cosine of pi over 3 is 1/2. Multiply the top and the bottom by 2, and you get to just square root of 3. So pi over 6, that's the reciprocal of the square root of 3. And if you rationalize the denominator, you get square root of 3 over 3, right? What else we got? So there's the graphs of secant, and I think that takes us back to the book. Okay, so let's go to the book and see about some exercises there. How about number 2? It says, show that P is on the unit circle. That means it satisfies the equation of the unit circle, right? So this is the review. Number 2, let me go and get that here. So show that they say 3/5 and -4/5 is a point on the unit circle. Okay, and so that just means show that it solves the equation x squared plus y squared equals 1, right? And this is 9/25 plus 16/25. That's 25/25 on a Tuesday, which is 1. And so where is it on the unit circle? Shall we locate it? Sure. Let's draw a little unit circle over here. And put in its coordinate axes. And so this is the point 1, I guess 1, 0. This is 0, 1. And so where is 3/5, 4/5? Well, if we chop this into fifths, those are perfectly evenly spaced hash marks. So we got 5 of them. Each one is a fifth. That's the y coordinate. The x coordinate is, so the y coordinate is negative, right? So we have -4/5 is here, and the y coordinate is -3/5, which I'm going to say is right there, right? So here's 3/5 and -4/5, and that leads to this point on the circle where x is 3/5. Right? Follow this down, and y is -4/5. And that corresponds to the the Pythagorean triple, right? That should be a familiar 9 plus 16 is 25, right? So you have a 3, 4, 5 triangle. If you scale it down by a factor of 5, you have a 3/5, 4/5 one triangle, right? Uh, there are other Pythagorean triples, right? There's the famous 8 squared plus 15 squared equals 17 squared, right? And so that means that, 8/17 squared. Today is the 17th, so maybe this is appropriate. Um, that's going to be one. So yeah, you can get pick any Pythagorean triple and divide by the square of the hypotenuse, and you've got coordinates uh, on the unit circle. So 8/17, 15/17. Um, we could do that in GeoGebra, maybe. Would that be a good thing to do? Do I have GeoGebra here somewhere? Somewhere. So I'm going to say circle centered at 0, 0 with radius 1. There it is. It's a tiny little thing. So let's zoom in on it. And notice it doesn't look like a circle because we've scaled our coordinate axes differently, right? But there it is, the famous unit circle. So if we plot the point, what do we have? 8/17 and 15/17. Boom, on the unit circle, right? But we can say, -8/17, 15/17, and we get its reflection in the y-axis, I believe. Sorry, find my 17. Yeah, and we can also reflect in the x-axis, right? So we have 8/17, comma, -15/17 down there, right? And if we negate them both, we get the point on the other side, right? So -8/17, -15/17. And notice, oh, what did I do? 16, not 15. Okay. And so we can also reflect across the line y equals x, right? So we'd get reverse x and y, and you'd get 15/17, 8/17, and that's a point over there, right? And then, all the reflections of that, right? So you can say, well, I can be on the other side of the circle, -15/17, 8/17. So that's over there. And reflect across the x-axis, we'd have 15/17, -8/17. Oh, sorry. I've got -81 here. There we go. And might as well finish this off, right? We're going to have -15/17 and -8/17. The comma. There they all are, right? And what is this little arc length, right? Can we get an arc length here? Yeah, there's a little menu that comes down here. I want an arc. Circular arc. So I'm going to say, give me the point at the center, give me the point that's the intercept there, and give me that. So what is that arc? That's D, which they say is 0.49. So I'm going to say, what is the arc whose angle is, and let's go to rounding 10 decimal places. Oh, now we got some accuracy, huh? So I'm going to say, give me the angle whose arc is, what's the sine there? 8/17. So arc's sine of 8/17. Notice that's exactly the same number as D, which was this arc, right? Down to the very last decimal place there, right? So, and you could do some more of those, right? Um, um, so we got this arc tool. Should we try another arc? So you say the center point, this point, and that point, right? So this is, they've labeled this, I don't know, E. And so I can say, give me the arc. Now, would you say cosine or sine? You'd say cosine because it's between 0 and pi, right? Sine wouldn't give you that. But if I say, give me the arc cosine of, what is that, 8/7, -8/17. Yeah, right. So this number here and this number here are the same number, right? 2.06, that's the distance from J to B along the outside of the circle, and that's the arc whose cosine is -8/17, right? All right, that's enough of that. Okay, so let's get back to the text. As much fun as that was. Yes, it's just doing the first problem from the text. Okay, so reference number and terminal point. So suppose in number 6, you've got, did I answer the second part? Suppose that P is the terminal. Find sine T, cosine T, and tangent T. Yeah, well, sine is Y, cosine is X, and tangent is the ratio of Y to X. So the tangent of T would be -4/3, right? Y, the ratio of X, Y to X would have the 5s canceling. You just get -4/3. Am I monitoring the chat? If you have questions, you can always put them in the chat. All right, so how about number 6 here? They say a real number T is given, find the reference number, find the terminal point on the unit circle determined by T, and find the 6 trigonometric functions of T. Okay, so T is -7π/6. And let's do all those things. So this is number 6 in the review. And we're going to say we're given that T is -7π. That means we're going clockwise over 6. Where are we on the circle? I'm going to pull out my lead here a little bit. Okay. And let's dial up our position. So if we count by π/6, that's 1/3 of π/2, right? So here's -π/6, here's -2π/6, which is -π/3. Here's -3π/6, which is -π/2. Here's -4π/6, which is -2π/3. Here's -5π/6, -7π/6, which is -6π/6, which is -7. And finally, -7π/6 is here, right? And so what are the cosine and sine there? Well, the cosine is -√3/2, and the sine is +1/2, right? So we get cosine of -7π/6 is -√3/2. Sine of -7π/6 is +1/2. The reference number for that is π/6. That's this distance here, right? And I'm not really using the reference number the way they want you to, because I just dial up the position and say, yeah, what are the coordinates there? Tangent of -7 pi over 6, well, that's going to be the ratio of y to x, right? So that's going to be -1/2 over square root of 3 over 2, and that reduces to -1 over square root of 3, which is negative square root of 3 over 3. Sorry, that's off the picture, all right? Okay. So what else do they want us to do? The other trig functions. All right. So secant of -7 pi over 6. Well, that's the reciprocal of cosine. So you'd say that's -2 over square root of 3, which more properly speaking, you'd rationalize the denominator, right? Cosecant of -7 pi over 6. So that's the reciprocal of sine. That's easy. That's just 2, right? And cotangent, that's the reciprocal of tangent, which is negative square root of 3. Just take the reciprocal of that guy, right? All right, what else we got here? The values of the trigonometric functions. So how about the cosine of 1.1? So this is 9, A and B. And they want us to, let's use the unit circle to approximate xy for t equals 1.1. Okay, sorry, we need to go over to the workbench here. Yeah. And so for that, we need a unit circle. And we need to mark out on the unit circle as best we can tenths of a unit, right? Because we're at 1 1/10, right? So let's make this a little bit larger and draw a circle like so. Coordinate axes then. So this is 1.57 approximately. And we're going to use that to sort of estimate, well, 2/3 of the way up there is then going to be, well, so 2/3 is pi over 3, right? And so just a little bit less than that is going to be 1, right? So I'm going to say there's 1, right? And then halfway to 1 is 0.5. And then we chop that into 5 equal pieces. Those are perfectly evenly spaced, no? And chop these into 5 equal pieces. Those are tenths, right? So 1 1/10 is right about there. So now I also need to chop this into a half, right? And then chop these into 5 equal pieces. So I have tenths on the x-axis as well. And I need to do the same thing up here, which I didn't really plan this very well. So I'm going to say that's a half. And here are tenths on the y-axis. And at least my spirit is in the right place, even if those are not perfectly evenly spaced. So if I drop a plumb line down to the x-axis, I'm going to be right about there. And if I draw a line straight over to the y-axis, I'm going to be about there. So I'm going to say, looks to me like the cosine of 1.1 is approximately, according to my calculations, somewhere between 0.5 and 0.6. I'm going to say closer to 0.6. Now, you might say that there's some hubris in that approximation. Yeah, I've got a preference for 5 and 8, so I like that. Sine of 1.1, what does that look like? Well, it looks to me like a little bit more than 0.8, so I'm going to say that's 0.85, right? Because so let's test that, right? Is that true? And how would you test it? Well, you'd use a calculator, right? Do I have one? Sure. So let's say choose all of these and unselect. Oh, let's just, I don't know. Well, let's just get rid of these points. Okay. Oh, I didn't want that point. Oh, now all the points are back. Great, thanks, GeoGebra. That's obviously what I wanted, right? Show object? No. I don't want to show that object either. Okay, so I want the point on the circle where we have cosine of 1.1 comma sine of 1.1. Right there. What are the coordinates? Well, I was pretty far off, it looks like, right? I had 0.58, and in fact, it's, oh, how did I end up so far off? Well, I think I put 1 in the wrong place to start out with, right? So if you look at, this is a lot farther along the circle than what I've got, right? Okay. But I had the right idea. So what I might do on the exam, what I've done before on the exam, is actually give you a better number line wrapped around the circle and ask you to use that to estimate what, but it turns out that this is a little bit farther along. So this is actually 0.4, what is it, 0.45? And this is, I wasn't too far off here. This is 0.89. Okay. All right, and do those satisfy the unit circle equation? Well, 45 squared is, this is, and this is, so that's 2025. So this is 0.2025 and 0.89. Well, I'm going to say approximately 0.8, right? Maybe a little bit less. And so, yeah, that adds up to 1, right? Or approximately, right? Moving on. So we got a bunch more of those. They say here, function from a graph. Yeah, so this is, you can make a graph of the function, or you can say, oh, given this is a sine function, what the graph of a sine function, what's the formula? All right, so let's do number 39 here, right? That's a fair game question. So let me try to reproduce that. We've got negative 1/3 on the left, and then 1/3, 2/3 on the right. Halfway between that is a thing and another thing there. So I've got a curve that looks like this, and the amplitude is 1/2. Okay, so let me show you what I've got on my paper. And so what would be a formula for this thing? Well, you can see that the amplitude A is 1/2, right? You can see that 2 pi over omega, or you can call it 2 pi over B, whatever. That's going to be 2/3 minus 1/3 is 1, right? So that means that what's omega? It's going to be 2 pi, huh? Yeah. What's our phase shift? Well, it's going to be 1/3 to the left. Or sometimes you say that's omega over phi, right? Or negative omega over phi is negative 1/3, right? Using the sort of those formulas. So if you have the formula D plus A times the sine of omega times T plus phi over omega, then you're going to have 0, right? It's oscillating around the x-axis. A is 1/2. The sine of 2 pi T plus 1/3, huh? So just plugging into those parameters. Okay, so that was number 39. Let's move on from there. You know, if you have a question, how did you get cosine of 1.1? I see it. Sorry, I missed that question. And Taylor, I think I missed your presence. So let me give you credit for being here. And how did I get the cosine? Yeah, so let's go back to that. Which what did I do with that? So the cosine of 1.1. So I said go distance 1.1 around the circumference of the circle and look to see what's the x-coordinate there. And apparently I did this not very well, right? It turns out 1.1 is actually closer to up here. And if I drop a plumb line down from there, I get you know, something between 0.4 and 0.5, which turns out to be 0.45. So I got the 0.45 using a calculator, but I wanted to say, you know, what does that mean in terms of the distance traveled around the distance, the value t, what is 1.1? That's the distance traveled clockwise around the unit circle from the x-intercept. And then you drop a plumb line down to the x-axis and you say, well, that's my x-coordinate there, which is the cosine of 1.1 by definition. Okay. We'll try to pay attention to the chat. Sorry for missing that when it came up. So we have more book problems. This is like a cosine curve, right? It's like a negative cosine, huh? With a shift, or you could think of it starting here at +4, right? You can see the y-coordinate there is -4 down here, so +4 up there. So it'd be 4 times. Well, let's just do it, shall we? This is number 40. It's a variation on the last one. So, but it's a cosine, right? So we're going to be at a peak here, at a trough here, another trough there. And this is one oscillation of the cosine curve, right? Which would continue on to look like, you know, typical sinusoid, right? Both to the left and to the right. But if this is 4, well, they tell us that this is negative 2 pi over 3, -4. That means that this is positive just by symmetry, right? -4. And so this is 0, 4. And this will be 4 pi over 3, 4. And so peak to peak is kind of an easier way for me to see that's the cosine curve. And then we don't have any phase shift, right? So we don't have to worry about shifting and negating. Just, you know, start here and end here. That's one oscillation of the cosine curve. And the amplitude will be 4. The phase shift will be 0. 2 pi over omega is 2 pi over 3. That implies that omega is 3, huh? And so d is 0. So this is going to be y equals 4 times the cosine now of 3x. And that's it, right? So the wavelength will be 2 pi over 3. The amplitude is 4. There is no shift. And either horizontally or vertically, right? Okay. So moving back to the book, we have graphing trigonometric functions. So yeah, I could be prepared for any one of these. How about 46? It's a tangent function. And maybe do 48 as well, huh? So let's do 46, where they want us to graph y equals tangent of x plus pi over 6. Great. And so this is just a horizontal shift of The tangent function. So if the input to the tangent function is negative pi over 2, then we have a vertical asymptote, right? So I'm going to say, look, I want the input, which is x plus pi over 6, to be negative pi over 2. Well, let's say either one, right? Plus or minus pi over 2. Those are going to be the vertical asymptotes. So I subtract pi over 6 from both sides. I got negative pi over 6 plus or minus pi over 2. If I subtract, I've got negative 2 pi over 3. And if I add, I've got pi over 3. I did a little common denominator in reduction to get those, right? So you'd say this is 3 pi over 6. If I subtract, I've got negative 4 pi over 6, which reduces to negative 2 pi over 3. If I add, negative 1 plus 3 pi over 6 is going to be 2 pi over 6 positive, which reduces to pi over 3, right? So those are my vertical asymptotes, right? And you know, if you want y equals 0 if x plus pi over 6 is equal to 0, which is x is negative pi over 6, right? So that gives us, I don't know, the vertical asymptotes and the intercept, which is really all we really need, plus the idea of what the shape is, right? So when we make a graph, we'll say, yeah, it's going to go from negative, oh, yeah, I should have emphasized more of the, how about over, I'll just draw another set of axes over here. So I'm just freehanding these. Oh, I did the same thing again. That's all right. We'll just extend it over to the left there, right? So negative 2. So if I have a table of values, I'm going to say this is a vertical asymptote. Negative pi over 6 is 0. And we've got another vertical asymptote here, right? So if this is pi over 6, this is pi over 2 pi over 6 is pi over 3. And that's a vertical asymptote. So I'm drawing a dotted line. If I go negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6. Sorry, this should be over 3, right? Negative 4 pi over 6, which is negative 2 pi over 3. So let's draw that like that. There's another vertical asymptote. The midpoint is negative pi over 6. That's where the 0 is, the midpoint between the vertical asymptotes, right? And then, you know, if you wanted to plot another point here, you could say, well, this negative pi over 2, I think is what this is, right? This is pi over 6. Oh, no, it's not. Did I do that right? So this is pi over 6. Yeah, negative pi over 6. Negative 2 pi over 6 is negative 2 pi over 3. Negative 3 pi over 6. Oh, yeah, I didn't do it right. Haste makes waste, as they say. So this is negative pi over 2 here, right? So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 is here. That's negative 2 pi over 3, right? Okay. And so this, I didn't draw this very well, right? But it's going to be a curve that looks like this. What's the y-intercept? Well, y of 0 is tan of pi over 6. What's tan of pi over 6? That's sine over cosine. Sine is a half. Cosine is square root of 3 over 2. So this is the one that's square root of 3 over 3. So that would be this intercept value there. Okay, that's a quick and dirty rendition of the tangent function for the input shifting to the left pi over 6, right? You see that shift to the left by pi over 6? Okay. How are we doing? Shall we do the secant one? We've got the secant of number 48 is the secant, y equals the secant. Well, it's going to be a multiple of the secant, right? So it's negative 4 times the secant of 4 pi x. Okay. So the asymptotes are where cosine is 0, right? Secant is the reciprocal of cosine. So the vertical asymptotes, which are really give it shape, right, are where 4 pi x equals plus or minus pi over 2 again, right? Where cosine is 0. And so that means that x is equal to plus or minus 1/8, just dividing both sides by 4 pi. Okay. And so if I make a table of values for this thing, I'd say negative 1/8, that's a vertical asymptote. 0, that's going to give me negative 4, right? Because secant of 0 is 1, negative 4 times 1. 1/8, that's another vertical asymptote. 2/8 or 1/4 is going to be positive 4, right? The opposite of this. And if I plug in x equals 1/4, I get secant of pi, the reciprocal of cosine of pi. Cosine of pi is negative 1, so the reciprocal of negative 1 is also negative 1 times negative 4 is a positive 4. And then 3/8 will be the next vertical asymptote, right? So when I go to make the graph, I'm going to draw, here's negative 1/8, 0, positive 1/8, 2/8, 3/8, right? And the vertical asymptotes are here, here, and there's going to be another one over here at 3/8, right? And then let's say that this is negative 4, and so this is positive 4. So I've got a branch of the secant down here and a branch of the secant up here. Okay, that's number 48. Questions about that? Is that good? Are we going too fast? Sorry, I'm trying to make time for looking over the other problems that we have to look at. Okay, so evaluating the expressions. So yeah, these are fair game. How about 52? What is the tangent of the angle whose cosine, or the arc whose cosine is 1/2? Yeah, let's figure that out. So number 52. Are we out of, okay, number 52? The tangent of the arc whose cosine is 1/2. So we want to figure out what arc this is, right? It's also the inverse cosine, right? Same, different notation for the same idea. And so dial up 1/2. Well, how do you dial up 1/2? Well, so you plot 1/2 on the unit circle, right? That's right here, where on the x-axis, because that's cosine, right? And what is this arc here? That's pi over 3, right? So this is the tangent of pi over 3. And the tangent of pi over 3 is the square root of 3. Got those memorized? Okay, so that's number 52. Phase and phase difference. Yeah, okay. So they say find the phase of each curve, find the phase difference between the curves. Yeah, I'm not going to do one of those. Okay, so let's say that that's out. And what do we have over in the second column? Fundamental identities, values of the trigonometric function. Find values of the remaining trigonometric functions given t from the given information. Okay, let's try number 20. Let's do one of our own, okay? So suppose that cosine of t is negative 12/13. So given cosine of t is negative 12/13, what quadrant could we be in? Well, there's two choices, right? X is negative in the second quadrant and in the third quadrant. So we have to be in one of those two quadrants. And so we need to specify which one if we're going to know the other 5 trig functions, right? By the way, is this a legal value for cosine? Yeah, it's greater than -1, right? Anything between -1 and +1 is a fair value for cosine. So let's say we're in quadrant 3. So we want to find the other 5 trig functions, right? So what's sine? Well, we can use the trig identity that cosine squared plus sine squared is 1, right? And that means that sine is plus or minus square root of 1 minus cosine squared. Yeah, that's a form of the Pythagorean identity. And which root do we take? Well, it depends on what quadrant we're in. In quadrant 3, sine is negative. So we want the negative square root, right? Of 1 minus the square of -12/13. That might seem daunting, but watch what happens. We get 1 minus 144 169ths, which we take the get a common denominator and subtract. And guess what? That's 25, which is a perfect square over 169. So that's -5/13. Okay, and that corresponds to the Pythagorean triple 5, 12, 13, right? So we're over in the third quadrant where this is x and this is y. Tangent of t is the ratio of y to x, right? That's going to be -5/13 divided by -5/12, right? Oh, 13ths, I mean. And oops, sorry, off camera. The 13s cancel. Oh, sorry, x is 12. That was given, right? 12/13. Okay, so that reduces to +5/12. And yeah, in the third quadrant, tangent is positive, right? And what about the other ones? Well, they're pretty easy, right? Secant is just the reciprocal of cosine. So that's going to be -13/12. Cosecant is the reciprocal of sine. That's going to be -13/5. And cotangent is the reciprocal of tangent. That's 12/5. All right. Horizontal shifts. Yeah, so what if you were asked to graph y equals 10 times the sine of 2x minus pi over 2? So graph, this is actually number 36 in the review section. Y equals 10 times the sine of twice x minus pi over 2. Well, I like to have my shift explicit, so I'm going to factor out the 2, and we get twice x times pi over 4, right? So that means that the amplitude is 10. The wavelength is given by, the wavelength of period is equal to 2 pi over 2, or pi, and the horizontal shift is equal to pi over 4 to the right. Yeah, and so when we make a graph, we might start with a table of values. So if we're starting at pi over 4, then y will be 0, right? Twice pi over 4 is pi over 2. Pi over 2 minus pi over 2 is 0. Sine of 0 is 0. 10 times 0 is 0. Okay, what's a quarter wavelength? So we call lambda is the wavelength. That's a common character. That's a Greek letter L for length. And that's pi over 4. Okay, so I want to keep adding pi over 4. And so 2 pi over 4 is pi over 2, 3 pi over 4, 4 pi over 4. 5 pi over 4? Yeah, so that takes me through one cycle. And the amplitude is 10, so I'm going to go up to 10, back to 0, down to negative 10, back to 0. So if I just plot those 5 points and draw a nice sine curve through them, I'm golden, right? Well, platinum, lead, tin, I'm good enough. All right, so here's the x-axis and the y-axis, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, perfectly evenly spaced hash marks. We're going to start at equilibrium and end at equilibrium. Then we're going to oscillate between 10 and back to equilibrium and negative 10, right? And so here's a curve. We're done. That's one oscillation, you know, it keeps going, of course, right? All right. Questions about that? Yeah, that was pretty exemplary of what you can expect. How are we doing? It's now the 13th hour. Even and odd functions, cosine is even, sine and tangent are odd, as the reciprocal functions go the same way, right? So the variable amplitudes, we're not going to do that. Solving trigonometric equations graphically. Yeah, that's pretty tricky. I think, you know, the trickiest thing we might have is, you know, combining two trig, like a sum of two trig functions. Which, what would that look like? Well, in the remaining time, let's go back over to the text. Oh, here's our antipode, is somewhere off of Madagascar. And so, you know, you see what I did here? I unpublished this because it turned out what happened there is I thought it was a chapter 5 exam, but it had been repurposed as a chapter 6 exam, and I'd written over the chapter 5 exam. So, you know, all bets are off with that. So let's concentrate on this one, which I think is exemplary enough. And I think, you know, all the solutions are here, right? So the answers are given. The last one says draw the unit circle and plot the terminal point P on it. So there you have it, right? Use the unit circle shown at right to answer the following. Plot the point negative 15/17. Okay, there it is, right? So x is negative 15/17. That's, I don't know, 0.8 something. Yeah, closer to 0.89, I think is what we said, right? Negative 0.89. And this is approximately positive 0.4 something, 0.45 or something for 8/17. So it says plot that point. Yeah, okay, here are the approximation on the unit circle. Start by doing the division to approximate these fractions as decimals to the nearest hundredth. Oh, okay, long division, huh? Oh, well, to the nearest hundredth, and that's, we've already got them, right? So I don't know. Approximate to the nearest tenth, the smallest value of t that will lead to the terminal point here, right? So yeah, we're basically counting around the circle by tenths, right? We get to 2.6 approximately. And so, yeah, 2.65 apparently, which I don't think I plotted that perfectly correctly. 2.5 is here. Yeah. plot the point of your circle to the first quadrant where x equals square root of 2 over 4. That's a number between -1 and 1. So that's, a point on the unit circle. Find and simplify the exact. So that's over here, huh? So we approximate 0.35. We look that up on the horizontal axis. It's right about here. We follow that up to the curve. We get to a point here. What's the y coordinate there? Well, to find the y coordinate, you need to plug into the equation for the unit circle. So the square of root 2 over 4 is 2 over 16, or 1/8, right? And so we're going to want the square root of 7/8. Or actually, this says, square root of 14/16, which is the square root of 14 over 4, right? That's the y coordinate there. Use the unit circle to approximate to the nearest tenths two values of t where sine of t is 4/5. Well, here's the y coordinate of 4/5, that's 0.8. And if you want the y coordinate to be 4/5, there's two places. There's one in the first quadrant where x is 3/5, and there's one in the second quadrant where x is -3/5, right? So it's a mirror image on the other side. And we'd like to know what values of t get us there. So you could do the inverse sine of 4/5. That will take you to this one here. If you want the one over here, how would you get that? Well, I would say the inverse cosine of -3/5, right? Because that's going to be a value between 0 and pi. All right, notice, let's do this on the calculator. So if we go to the calculator and we say, give me the inverse arc sine on this calculator here of 0.8, right? That'll be 0.9. Oh, 0.92. Oh yeah. So yeah, go back to the circle. And how far are we traveling? What is the arc that takes us to a y coordinate of 0.8, right? And you can see it's a little bit bigger than 0.9, right? This big dot here is, that's 1.0, so the hash mark before it is 0.9, and we're just a little bit beyond 0.9, so we're at 0.92. But if I were to ask what is, how do I get to here? Well, there's two ways I could get over here. I could say, well, it's pi minus this distance, right? Just by symmetry. Pi is on the west coast here. And so if we go back this distance from pi, clockwise from pi, the same distance over here, we'd have pi is 3.14, and subtract 0.9 from that, you're going to get 2. What is 3.14 minus 0.92? I'm writing that down here and computing it. It's 2.22. Yeah, so to the nearest tenth, 2.2, right? So that would be one way of getting it. The other way would be to use an arc cosine of -0.6, right? Let's do it that way. So back over in the calculator, if I ask for the arc cosine of negative, got to be negative to get into the second quadrant, right? Where sine wouldn't do it, but yeah, so this says 2.2, yeah. But if we do the, yeah, we can't get that using arc sine because that's not in the range of arc sine. The range of arc sine is -pi/2 to pi/2. Pi/2 is only 1.57. We're getting a number bigger than that, 2.2, right? All righty. What else we got here? So Suppose that sine of t is root 15 over 4. Is that a legal value for sine? Yeah, it's a little bit less than 1. So you're pretty close to the North Pole, penguin land. But cosine is negative. That means we're in the second quadrant, right? Simplify the values for cosine, tangent, secant, and cosecant. And for that, we use the Pythagorean identity, or you can think of it as the equation for the unit circle, right? X equals the negative square root of 1 minus y squared. Y squared will be 15/16. So you get a nice clean negative 1/4 for X, right? And so on. What else we got here? Yeah, draw a graph of this function. So you got a vertical shift by 2, got an amplitude of 4. So you're going to go up and down 4 from a horizontal of 2. You've got a wavelength of pi and a shift of pi over 8, right? So we start, your table of values start at pi over 8. A quarter wavelength is pi over 4. So we add 2 pi over 4 to pi over 8. We get 3 pi over 8. That'll be 4 up from the equilibrium. So we're at 6. And you draw your 5 points, plot them, and make a nice smooth curve. And then it says, reverse engineer, right? So from the graph, get the equation. And we see that the amplitude is 4, the period is 360. That's 2 pi over b. That means that b is pi over 180. So you got to write 2 pi over b equals whatever the wavelength is and solve for b. Are we out of time? Oh my goodness. So here, then you got a graph of a secant and a couple of inverse things. Okay. Is it obvious that this is negative pi over? That's not so obvious, huh? The sine of 7 pi over 6, you're into the third quadrant where the sine is negative 1/2, right? But the arc whose sine is negative 1/2 has got to be between negative pi over 2 and pi over 2. So it's the opposite side of the circle. It's the antipode of 7 pi over 6, which is actually, it's not it's the reflection across the y-axis, right? Where the sine, it's got to be negative, right? The sine of 7 pi over 6 is negative 1/2. The arc that will take you to a y coordinate of negative 1/2 that's in the range of the inverse sine function is negative pi over 6. So that's a little confusing, right? It looks like, the function and the inverse function should undo one another. Not in this case, right? So the arc, whose cosine is 3/5, that'll be in the first quadrant. And you can find the y coordinate is 4/5. And so y over x at that point is 4/3. 4/5 to 3/5, right? And that's it. Okay. So we'll have similar kind of problems mañana. Any questions before we break? Sorry, went a little over. Seems to be the way of it. All right. We'll have a pleasant afternoon. And let's see who's here. Do we pick up some people? These are the brave, the stalwart, the few. Oh no, not so few. We've got more than we started with. That's
Excuse
good.
me, Professor.
Go ahead, Dylan.
Could you post this recording into Canvas when class is over?
Yeah, I'll tell you what I'll do is I'll post so what I do is I usually get an unannotated one first, and then a while after that I get the annotated one. I'll put up the unannotated one since, yeah, that makes sense.
Thank
Sure.
you.
Okay. All right. So
I came in a bit after your role.
oh, Carla?
Yeah.
Yeah, and you need to tell me what your situation is tomorrow. We can
Okay,
figure it
okay.
out. Okay. So Carla Medina. Yep, got you. Anybody else? Leonardo, did I get you? Yes, I did. Okay. Jadzia. Yep, I got you. Tia, did Tia come in? No. All right. So I'll show up a little early tomorrow and we'll go a little late for those of you who want to do that. And that's a wrap. Have a pleasant afternoon.